Hello everyone, welcome back to the channel. So in this video we'll be talking about what is data structure, right? Very interesting question, to be honest. Even in my interview I was asked this question. There my answer was a bit different because I knew it in general. I told them, yeah, array is a data structure, linked list is a data structures, and I was not able to explain it properly, the implementation or anything. That was long back in my academics. So today we are going to get the answer of it for sure. So what is DSA, right? As we already know the full form, right? Data structures and algorithm. In our academics, this subject is also known as DA, which is the design and analysis of algorithm, right? So that was a subject which was mainly we used to learn to improve our programming concepts, understanding in general. So yeah, let's come to the understanding of the actual thing. Before you even go into learning this DSA, right? Your question might be, why should I even learn this DSA, right? So first thing, it makes you a better programmer for sure, right? Because the whatever libraries or frameworks you're using, right? Sometimes even a complex implementation, the understanding of these data structures, right? It helps a lot. Even the algorithms that you're following, whether it could be for some searching, sorting, basically things like that, right? It makes you a better programming in general. Also, it makes you a software engineer, actually better software engineer in general. So yeah, that is there. You become a better problem solver, to be honest, because these problems that you will be solving using data structure algorithm, right? You will be understanding there is a bad way to do it, bad way to solve those problems, and there is a better way to solve those problems. That understanding is not just limited to using those in the projects or this code and all, right? Like understanding creates a great impact on the brain in general, right? So in general also, whenever you're beyond your work, you think of optimizing the task or doing things in a better way. So yeah, that helps, it helps there as well. And these are practical things, that's why I'm sharing with you. So yeah, that is there. And also one very popular thing that you already know is that it helps in cracking a big those fang name, right? uh, Companies interviews as well, because out of their 100% interview process, they ask it for almost 80% of their whole interview. So yes, it creates a big impact if you know these data structure algorithm, their implementation, use cases in general. Yes, so there is that. And also, before I continue, I want to tell you the other series that we started, right? That Java interview series. Will be continuing that also, but it will be parallel, right? So I don't want to just start on that particular series, because there are multiple things that I'm exploring, right? And there is a good content also that I'm able to create on that particular topic. So I don't want to just limit myself to one of the series, but you'll be getting for videos for that also for sure. So yeah, let's start with today's topic, that is data structure, right? So what is a data structure? So it is a way, in a simple way, if I tell you, it is a way of organizing data so that you can perform certain operations on that particular data in an efficient way, right? Now what does it mean, right? Let's take an example of my room itself for data structure, right? So in my room, let's say I have a particular bed, right, where I'm putting my clothes, right, where I'm putting my all the electronic equipments, right, where I'm putting my guitar, my this laptop, my boxes and all those things, right? Everything at one place, right? And I'm outside my room, you're with me, right? I'm telling you, you know get a single nail cutter from my room, right? And you say yes, that's fine, right? You enter in the room, you see everything is on the bed, right? It will take you a huge amount of time to go through all the stuff to find that nail cutter, right? Even after that, right, you will get frustrated, your time will get wasted, right, your energy will get wasted, right, and you might even break it. I don't know how, but there is a possibility, right? So that is one thing. So you saw how much resources we wasted, right? We wasted your energy, like if everything is at one place, right, in a congested way. You wasted your energy, right? You wasted your time, right? Your mental peace got disturbed because you literally had to go through it in a very intensive way, right? So you lost those many resources. Especially the most important of those resources is time, right? The time that you lost there, right, that's not going to come back. So now let's think of a better scenario. In my room, there's a cupboard for all the electronics. There is a cupboard for all the clothes, and there is a cupboard of all the general stuff like trimmer, nail cutter, whatever I was talking about, right? And it is arranged in such a way that you are able to see. If you want to like go for the nail cutter, you don't have to go to the clothes cupboard or electronics cupboard, right? You just have to go to the general cupboard, you see the nail cutter right there, you pick it and you come back, right? There is no energy wastage, there is no time wastage, your mental peace is already there with you, right? So it's a win-win for everyone. So what we did, now let's consider all of those electronics, clothes and all those things, right, as a data, right? What I did basically, I organized that unorganized data in such a way in the cupboards so that whoever is able to trying that retrieval operation, retrieval means getting it from the particular cupboard and getting it back, giving it to someone or something, right? That operation, so I organized it in such a way so that whoever is trying to access that particular data, they are able to do it in the most efficient way possible, right? And all the resources were saved. You see, this was the real world example of what a data structure is basically. Now that particular cupboard I'm considering as a particular data structure here. Now in Java, we have data structures like arrays, linked list, right? Hash table, stack, queues, trees, graph, heap, right? Every data structure has its own importance. Every data structure has its own structure where the data is organized in such a way that if you have a need to perform that particular operation, right? For example, getting nail cutter from there and giving it to someone was a retrieval operation. Data got retrieved and I'm giving it to someone else, right? So that is the retrieval operation, right? So all of these data structures have a particular structure of their own where a certain operation can performed in the most optimized way. That is why you have these many data structures, because one data structure cannot perform all the operations in the most optimized way, right? Some data structures are good for retrieval, getting data back. Some data structures are good for saving it, right? Like putting it there, right? And some are good, let's say I have 100 nail cutters, right? God knows why do I have those many nail cutters, Hana? Just imagine I have those in a particular cupboard or something, right? To search for a particular nail cutter also, it might take some time, right? Even that can be done in the most optimized way, right? You have hash table, there hashing is done, right? Where putting the data, putting some value, getting some data, everything is done in the most optimized way, which is basically O of 1. Just find the particular hash key of that particular value, and we'll be discussing those things later with the implementation and everything. Let's not get confused for now, right? So yeah, that is one of the example of how I have taken the example of my room itself to explain you what data structures is, and those are the data structures we'll be understanding. That if you have already like if you already have arrays, right, why do you need linked list? If you already have these linked list, why do you need stack or queue, right? So there is a order is already included there, like FIFO, LIFO, last in first out, first in first out. Why that those orders are important, where they are actually used, all those things we'll be discussing. The way we go ahead in this course to reach those data structures, we'll be discussing all those things in detail in a very proper way. So you understood what a data structure is, right? So it is a way of organizing the data in such a way that the operation, that any of the operation which is performed on a data structure can be performed in the most efficient way, right? So that is the data structure simply. So in just one liner, it is a way of representing the data. That's it, right? And I told you, right, these different operations we will be performing on those data. Those operations are actually nothing but algorithms, right? There are bad algorithms, there are good algorithms, that we'll be discussing in the next video, right? So yeah, that is what a data structure is. It is a way of organizing data in such a way so that operations can be performed on the data in a most efficient way, right? Next time if someone asks you, take the example of your own room, or if you have a better example, go ahead for that. This was mostly a theoretical video, and next one also will be theoretical one till big O analysis, like asymptotic analysis, big O notations. It will be a bit theoretical, I understand. From arrays, it will be very practical, because once I tell you, right, what is array, I'll be implementing the array list in front of you. So you'll be able to understand, okay, this is how the implementation goes. So then that's when it will become more interesting with the implementation and all, right? So yeah, let's end this video for now, right? That's it. I hope you understood what a data structure is. See you in the next video. May the source be with you. In next video, we'll be learning about what is an algorithm.